Hello everyone, engineers, good day for you. So this is Abbas one with you. Today we are going to continue the course of Staad Pro. We are going to be discussing a new example so we could get more advanced ideas about Staad Pro. So let's begin. First of all, open your Staad and hit the new project as we used to do, space meter kilonewton. Okay, and here we are going to call it project 2. Alright, so we hit next and add beam, then finish. Okay. So as you people know, we work on the 2D dimension. Okay, so just hold on, let me do this. Okay, so we work on the 2D dimensions. Okay, so let's see our example here. As you can see, here we have this drawing. So it begins with from 0 to 20 to 15 to 9 for the y-axis and 0 to 13. Okay, let's draw it so I can give you more details and you can understand me better. So we hit on create and we choose the irregular. Here we have x0, and then as I told you, we always begin with 0. Okay, so as we talked before, that we put a node like this, nodal. Okay, hold on, let me see here. Okay, nodal like this. Okay, we put one like this. Okay, when we have a change in the section or the material, or we have a concentrated load. So in this example, as you can see, we are going to begin from 0 to 30. Okay, but the problem is we have a node before, so we are going to separate it. Okay, so this concentrated load made a node here, so we are going to draw from 0 to 15 to 15. Okay, so 0, 15, 15. And for the y, it's 0, 20, 15, 9. 0, 20, 15, 9. Okay, 0, 20, 15, 9. Okay, and let's give it a name, triple C. Okay, here we are, and then we choose it like this. Now we need to draw. So please focus with me about the way I'm going to draw this this exercise. Okay, just hold on with me. So from here to here to here to the half of the 44, then here, here, here. So someone will ask, will say, oh, okay, what about those two beams, this one and this one? Okay, I'm gonna show you the method to draw those beams. So I cannot actually begin from here, then here, then here, then here, then here, then come back here. Now it's not practical. So there are kind of options that helps you to draw this beam or structure correctly. So we head to the geometry tab and we go to the add beam. So we have three options, which is from point to point or midpoint or the perpendicular. So for this lesson we are going to use the point to point adding beam. So we head on this and please focus on this point. Okay, so when I'm going to draw from here to here. You might be drawing from right to left, but I've drawn from left to right. So this is important. Focus so you can understand what's happening. Just focus on what I'm saying. Don't say, oh, why, what's the difference? No, you will know after. Okay, so just focus with me. So I'm going to draw from left to right. You can draw from right to left, okay, but this will it's going to give the same answers, but I'm just saying this to make you focus. Okay, so as you can see, we have drawn one here, so easily using the add beam, which is add beam from point to point. So the thing is, as I told you, here we have like 1, 2 nodes. Okay, oh, we need to add them. How could we add them? We have 3 here, we have 2 here, we have another 2 here. Oh god, that's a big problem. So let me show you how to add those nodes. Okay, nodes. Okay, so let's hit here and we hit this one, insert node, and we hit this one. How many nodes we have here? We have like 2. So we have 2 here. Add endpoints. Okay, no problems. And for here we have 3. So we click here. We add 3. Add endpoints. Okay. Here we have 2. And here we have another 2. Right? Am I correct? Okay, so 7.5 meters, 7.5 meters. Let's make sure that we have done everything correctly. We had the tools and tools, dimensions, beams, and display. Okay, it's 7.5, 7.5, 7.5. We've done everything correctly. Okay. So, is there anything else we need to do? Yes, there is just one left. As you can see here, we have trusses. How we are going to draw trusses in Staad? Actually, there is no direct option or an order to do here and Staad to draw trusses. It's actually like indirect method. So the method is like this. You need to go to the geometry again and add beam from point to point. And you do just like this. This from here to here, here. As you can see, we have drawn just like the structure we have here. Alright, so we have drawn everything. So it's time now to hit to the general section. So as you can see here, we have this tab called properties. What we do with properties. So here we have a definition to the sections. We have W14 by 19, W10 by 49, 2115, 1835, and we have an angle which is 40404. Okay, 40404. Okay, so we are going to add those to our sections. Okay, so we can make a definition to the structure we are drawing. Okay, so we head to the section database and we add the 1490. Okay, so 1490, where's that? Here it is. Yep, 1490 and 1049. Here we hit down 1049. Here it is. We add it. And 21 multiplied by 50. 2115. 50, sorry, 2150. Okay, so 2150. 2150. And here we go. Add 2150 and anything else? Do we have another? Yeah, 1835. 1835. Here we have 18 and it's 1835. Here it goes. Add. Okay, so the last thing we have is the L section, which is the angle for the trusses. So we head to the angles here, you see, this one, and we look for 40, 44. 40, 44. 4040. 4. Okay, 40404. Okay, where is it? Here it is. 4044, and we hit add. Then we close it. Okay, so let's assign them. Okay, so for those, hit Control to add another one. Okay, we have here 14 by 90. We hit, sorry, again, and assign to selected beams. Sure. Okay, and those are assigned. Okay, so this one is 1049. So 1049 for this one, and assign, yes. And here it's 2150. 2150 for those. Yes. And for this one we have 1835. So 1835 for this. No, not you. This. And oh god, I'm sorry. The second time. Okay. So don't do my mistake. It's really annoying. Okay, this one. So the last thing we have is the trusses. We need to do them like this. Okay, and oh god, again. Okay, this time trusses. To hit assign. Okay, so after we have made the definitions of the sections, we head to the specifications. Okay, so what we are going to do here, we have drawn the trusses, but they are still defined as beams. We need to tell the Staad that those beams are not beams, they are trusses. So we go to specifications and we hit on the beam, we go to the truss and we hit add. Okay, so what are the trusses you want to define? Here they are. Okay, and we hit assign. Yep, and they are assigned as trusses. Okay, so there is something we need to notice here. We have here a node or node, okay, node that is released. As you can see, this node is not like this. This one is released, this one's not. So we need to release this node, which is this. We need to release it. So what should we do? Okay, so before that, I want you to focus on something. Remember when I told you when we used this one, add beam, and we draw this beam and this beam, and I told you I'm going to draw it from left to right, and if you want to draw it from right to left, it's up to you. You remember that, right? Okay. So, according to the way you've drawn, as you can see, I have a green light at the left and a blue one at the right. Okay, so this is according to the way I've drawn. So you might have it oppositely. So you might have the blue one at the left and the green one at the right. So what does those colors means? So the green means start and the blue means the end. Okay, so the green one indicates to the Z and the blue one indicates to the X axis. Okay, and the red one indicates to the Y axis. Okay, so when you hit on this one and you want to make a release for this node, so you just go here on beam and release. Okay, so as I told you here, I have green, so green means it starts. So you might have blue here again. So here I have green light, you might have blue light. If you have a blue light at the left, it means it's end, not start. So I have green here. Okay, so I hit beam and I hit start. Why? Because it begins with green. Okay, so here for me it's green. Okay, let me see, here for me it's green, but you might have blue. Okay, it's according to the way you drawn. So if you have drawn your drawing and you have it green start beside the release, you need to hit on the start. Okay, another thing you need to know, okay, go to this symbols and labels and hit it. Here you can see the nodes numbers and beam orientations. Hit apply and okay. As you can see, we have the red and the blue one. So the red indicates the y-axis and the blue one indicates the x-axis. Okay, so those are not the global axes, those are the local axes. So for this one you have the y-axis this way, you see, this way. Okay, for this one you have the y-axis this way and the x-axis this way, so it's not the same. Okay, so these are the local axes. Alright, so you hit on this again and as I told you, it's green for me, it might be blue for you. You go to the beam and you hit on release. You want to make a release for this node. So for me, I'm going to hit start, and since I have the local axes y and x, I'm going to make a release for the moment z. Okay, so I'm going to hit add, and I'm going to hit assign. You see, made the release here. So I'm going to remove those beam and new numbers, and okay. Alright, everything is clear? Okay. So let's go to the next one, which is the supports. Okay, so one thing about the supports you need to know. Here in our drawing we have, or our structure, we have like fixed one and append one. Okay, so sometimes it might ask you to, like, okay, I want you to make a ruler, and I don't want it to move on the y-axis. What should you do then? Okay, you are going to go to create and not choose pinned. You are going to choose fixed but. So if someone told you, oh, I don't want it to move, I want a ruler here, and I don't want it to be moving on the y-axis. So what you're going to do, you're going to hit all of these except y. So you are going to make a release for all of them except y. Okay, but for the purposes of this lesson, we are not going to use that. So we have fixed and pinned. So we add fixed one and we add a pinned one. Okay, so the fixed one is for here, assign, yes, and the pin one's here. Alright, so we are finished from the support. We go to the loads and definitions. So let's get back to our drawing, and as you can see, we have live load, and live loads here and here, and wind load WL. Okay, but we don't have any kind of dead load, but for sure there is something called the self weight. Okay, so we are going to draw the forces of our structure, but before, let's open a notepad and try to make like a conclusion for the forces you have. So we have a dead load, which is the self weight, minus 1 kilonewton per meter. Alright, and the second one, we have the live load. We have concentrated and distributed. As you can see here, this one is concentrated, which is 15 kilonewton concentrated, and we have a distributed one as well as here. Okay, so we have concentrated 15 and minus 35, which is this and this. Okay, and we have a distributed load of 1.2. Or is 1.2? Okay, it's here, and another one which is 0.9, which is here. Okay, so, and for the wind load we have the 0.6, and for the another wind load which is minus 1. Okay, so as you can see, we have something called like local axis. I'm going to make an explanation for that. Okay. Okay, just focus with me. Let's get back to our question or our example. So we need to make load cases. Okay, let's make one. So for the first one, it's going to be dead load, and the second one's going to be live load, and the third one's going to be wind load. Okay, so we are going to close this one, hit on this, and as we said, for the dead load we only have the self weight. Add and close, and when we want to assign it, we are going to assign it for all the structure. Okay, and it's done. So easy. So for the live load, we are going to hit add, and we see what we have here. Live load, we have two concentrated force, minus 15 and 35. So we head to the nodal load, minus 15, okay, and minus 35. As you can see here, we have both here, minus 15 and minus 35. So what we have else? We have distributed. So we close the noodle, we go to the member. distributed one as minus 1.2, minus 1.2, and we hit add. And for the fourth one we have minus 0.9, and it's for the local y. What does it mean when I say local y? Remember when I've showed you when we hit on this one, symbols and labels, and you saw the local and local axis for every one of, or every piece of the structure, every members, right? Yeah. So when we are saying that minus 0.9 for the local y, why didn't I say global y? Okay, let me explain that for you. So we have minus 0.9 here, okay, which is inclined. There's an angle, so there's nothing I can tell the Staad like, oh, where's the angle? No, there's nothing called angle here. But to make it easier, okay, I'm just telling the Staad that okay, don't worry, I want you to put this distributed load on the local axis for this member, which is like this, you see. So this is the beam, which is this, okay, and this is the distributed load, for instance, okay, and this is the local y, okay, and this is the local x is going to be this way, local x going to be this way, okay. So that's the point. Okay, so local y and local x. Okay, so instead of giving him an angle and stuff like that, okay, so I'm going to tell him to use the local y-axis. Okay, so this also applies to this one with wind load. Okay, let's just continue. Minus 0.9, right? Okay, which is for local y-axis, right? Okay, and we hit add, then close. For the force 15, okay, let's see here. For the force 15, which is here, we have, sorry for that, here we have 15 concentrated load, live load, and as well here. So what shall we do? We use the nodes cursor and we do like this, okay, and we go to the assign to the selected nodes and assign. Okay, as you can see, the 35 is here, minus 35, we go here and we do this, okay, and assign to selected nodes, assign, yes, as you can see. So minus 1.2 kilonewton per meters, where it is, it's here. Okay, so we come here, we choose the beams cursor, we do this, and assign to selected beams. Okay, very good. For this one, 0.9 for the local y, which is here, 0.9. We have 0.9 here and 0.9 here, so it's going to be on both of those beams. So we're going to do this. No, not you. This. I'm going to hit on that and assign to selected beams. Yeah. Okay, and it's done. So now it's time for the wind load. We hit add. So we don't have any kind of axial load. We are going to hit to the member load. We have 0.6 for the global x. Now you'll see why. 0.6 for the global x. Okay. So as you can see here, this one, we could say it's for the local y or for the global x. Okay, because it applies with the direction of the global x and also applies with the direction of the local y for this beam. So you can choose either the local y or gx. So I'm going to choose gx and hit add. Alright, and for this one, minus 1, which is this. Yep, I'm going to add another one, which is minus 1, and it's going to be local y. Okay, add, close. Okay, so we're going to choose these two and assign. Yeah, 0.6, right? Yep, and this minus 1 for this one, and we hit assign selected beams and assign. we are almost done. Okay, so the extra thing we are going to do is we are going to make something called load combinations. So it's like 1.2 did load plus 1.6 live load equals stuff. Yeah, so we hit on this and we hit on add define and combinations. Okay, so 1.2 multiplied by did load and 1.6 multiplied by live load, and we hit add. So this is the first one. This is the first combination. Okay, so suppose that the second one is 1 did load, 1 live load, 1 wind load. Okay, add 1.2 did load, let's say. Okay, sorry. 1.2, 1 for live load, 1.3 for wind load. Okay, so you might say, no, where did you get those numbers? So I'm saying that if you have any kind of, like project, you will have this kind of numbers. You will be asked to make combinations. Alright, so now let's go to the last step, which is analysis and print. Okay, and we hit add. Let's see if we have any kind of problems here. So run analysis, save. Let's see, hopefully not. Yes, we don't have. So then we go to the post-processing mode. As you can see, we have a lot of cases. We are okay. So this is for the node. We have the displacement. You can change it from here. This is for the wind load. If you choose the did load, it's going to change, as well as you can see here, right? If we go to the reactions, you can see we have the reactions for the X are going to change when we change to the live load. We're going to change to the wind load, and so on for the Y and X. Okay. Okay. So if you want to know the shear or deflection at any of those cases, you just hit here. You have the bending and the shear. Okay, so this is for the did load, for the live load, for the wind load, for the combinations. Okay, as I just did at the last lesson, you can come here and see the value, the information. So you can see the deflection as well for the live load, for the combinations, for the okay. So this is all for this lesson. Okay, I hope you had a good idea about what we did at this lesson and could recognize the method to do this example properly. I'm going to make an attachments for you people so you can easily download material and be able to see what we're doing. Okay, this is all for now. Thank you for your watching, and this is Abbas One was with you. Bye bye.